Okay, we're looking at topic 7, which is parallel lines, the reassessment for that. And the first 6 problems, we are just identifying what the type of relationship is. So we're looking at the transversal, and the two angles that we're looking at are on opposite sides of it. So we would call those opposite because they're on opposite sides of the transversal. And they're interior because they are inside of the other two lines. Okay, let's look at number 2. We have lines that are on opposite sides of the transversal and again interior. So we have the same thing, opposite interior angles. Okay, going down to number 3, we have now lines that are angles that are on the same side of that transversal. So they're now same side. And they're inside of the lines, so interior. So we have same side, interior now. Same side, interiors. Okay, let's look at the next set. We have lines that are on opposite sides of the opposite sides of the transversal, and interior again because they're inside of the two other lines. So these are again opposite interiors. Okay. Number 5, we again are dealing with opposite interior angles. They are on opposite sides of the transversal, and they are inside of the other two lines. In number 6, we have opposite sides of the interior, and now we have exterior angles. So these would get the title opposite exterior angles. Okay, so now with 7 and 8, we're looking for what the value of the angle is. We need to know the relationship to find that out. So in 7, we're dealing with corresponding angles, and they would have the same measurement. So if one of those is 110, the other one will be 110. In 8, we are dealing with vertical angles. They're across from each other. They have the same measurement, so if one is 105, the other is 105. Moving on to the back page, we have 2 more where we're trying to find the measurements of it. If we look at D, we again have vertical angles here. They have the same measurement, so if one's 102, the other is 102. If we look at 10, our relationship here is that these are same side interiors, and they're going to add to 180. So 80 plus 100 would give us 180. Okay. Same idea. We're looking to find the value of the angles. And this time we have some expressions in it, so we're going to have to set up some equations and solve for them. We have alternate interior angles here. We know that they equal each other, so we would write an equation. It would be 10x equals 11x minus 5, and then we would solve it here. If we subtracted 11x from both sides, we get negative 11. Negative 5x is 5. Divide both sides by negative 1, we get x equals 5. We're asked, though, to find the value of this angle, and that would be 10 times 5, which is 50. So our angle measurement would be 50. 50 is our actual answer. In B, we have same side interior angles. And we know that they add up to 180. So we could write our expression or our equation here to have the first angle, x plus 105, plus the second angle, x plus 95, equal to 180. This would, when we solve it, we would end up with 2x plus 200 is 180. Would give us 2x is negative 20. We divide, we get x is negative 10. Remember, we don't want what x is, we want the value of x plus 105. So to substitute that in, we'd get negative 10 plus 105, and we would get our answer of 95. Tell us that that angle there is 95. Okay. In 11, the type of angles we're dealing with are same side interiors. We know that they add up to 180. So we'd write our equation again to add both of them, 13x plus 24 minus 5, and it would equal 180. We would solve it by getting, missing an x there, 24x. Those add together to give me 37x. When I add 5 to both sides, I get 185. When I divide both sides by 37, I get x equals 5. We again are not interested in what x is. We're interested in 24x minus 5. So we'd have to do 24 times 5 minus 5, which gives us 120 minus 5, which is 115. So the value of this angle is 115. Okay. When we look at 14, we see that we have corresponding angles. It slid down the transversal and is in the same location. Corresponding angles have the same measurement, so our equation would be one of them, 2x plus 9, is going to equal the other one, 22x plus 3. Now we just have to solve this for x. If we were to subtract 21x from both sides, we'd end up with x over here, and subtract 3 from both sides, and we get x equals 6. We are interested in what 21x plus 9 is, though, so we'd have to do 21 times 6 plus 9, which would give us 126, which I wrote backwards. That is 126 plus 9, which is 135. So this angle here is 135. Okay. Now to show that something is parallel, we're going to be using the converse of these theorems. And in this case, we're going to be showing what value x would have to be for the lines to be parallel. So we'd see what relationship we have here, which is corresponding. They'd have to have the same measurement. So this value here would have to be 124, same as above, for those lines to be parallel. When we look at 16, we also have corresponding angles. We know that those would need to be the same for those lines to be parallel, so we would set up our equation. The first one, x plus 27, is going to equal the second one, 76. When we subtract 87 from both sides, we get x equals negative 11. That is our answer, because we're asked to find the value that makes the lines parallel. Only when x is 11 do those lines become parallel. Anything other than 11, they are not.